All right, so good morning, everyone. Let's go over this notebook that I made for you yesterday. Okay, let me move this little bar thing maybe up here. Okay, so NetworkX is a Python package for studying networks and graphs. And it's pretty well documented. This is the newest version, version 2.6, which we'll be using this fall. And I encourage you all, as we're finishing up the semester, to go through the tutorial and understand the documentation that they give you, even though I'm going to make my own for you. It just so happens that theirs is pretty good. They miss a few things, but I think that overall you can get a sense of how things work. So in particular, the tutorial and the reference, and then just maybe understanding these things here. I'll help a lot with the drawing part. Okay, so let's go back to my notebook. Okay. So in this lecture, we're going to learn the basic functionalities of NetworkX. In particular, we're going to learn how to create simple undirected graphs with no weights on the edges, just normal simple graphs. Okay. And if you've been watching my lectures, you should know what a simple graph is. It's a graph with no loops, no multi-edges, and no direction on the edges. All right, so we're going to use NetworkX, and typically we will give NetworkX the alias NX, and we're going to use matplotlib pyplot to help us plot some of the, draw some of the graphs. Okay, so let's go ahead and run this. Okay. So I think the easiest way to understand the graph object, the NetworkX graph object, is to instantiate a graph as empty, meaning that there are no nodes and no edges. Now, strictly speaking, an empty graph, from the point of view of graph theory, some people would say that it is a set of vertices with no edges. So this is like a trivial graph. But in terms of NetworkX, an empty graph is this. It's precisely a graph with no vertices and no edges. And notice here that I wanted to print out the type. So for those of you unfamiliar with Python, this is an F string. So if you put an F before you type your string, then inside of curly braces, inside the string, you can put whatever you want and it will convert it to be a string. So basically here I instantiate the graph, and then inside of this F string, I just show the type. So the type of G is this. And this is a networkx.classes.graph. Okay. And there are other types of graphs. This is just the simplest type here. Okay. So this is something that I've been emphasizing the entire semester. All Python objects, so everything in Python is an object, and objects have attributes and methods. And when you're dealing with a new type of object, it's important that you understand what the attributes and what the methods are for that given class. So if you click on this link here, it should open up the graph class, and then you will see what the parameters are, and then you can look up the attributes and kind of go in and see like what you can do with a graph. Okay, but we're going to explore the basic properties of the graph class in this notebook. Okay, so if we would like to see the nodes, the nodes is an attribute of the graph. So if we just do g.nodes, this should show us the nodes. And the edges are also an attribute. So if we do g.edges, we should see the edges. However, since the graph that we instantiated has no vertices and no edges, the nodes and the edges are empty, and these lists are empty. But let's go ahead and change that. So let's add nodes to G using the add node method. So notice this is a method. There's parentheses right there. And I encourage you to look up the documentation and just, it's very simple. If you want to add a node to the graph, you just do this, right? So g.add node, g.add node. So I'm adding 4 nodes, A, B, C, and D, okay? So now if I print the nodes, I print the edges, you'll see that now the node list has A, B, C, and D in it. And the edges are still empty. We haven't added any edges yet. So let's use the add edge method to add edges to G, okay? So the way that you do this is by calling add edge on G, so g.add edge, and then you pass it 2 nodes that you'd like to be adjacent, you'd like to add an edge between. And the order of this doesn't matter, we're not dealing with directed graphs here. So you could do BA or AB, it doesn't matter, okay? Now, so we add how many edges? 1, 2, 3, 4. So now if we print the nodes and print the edges after calling that, you'll see now that we have a list here of the nodes right there. And then underneath it, we have the list of the edges, okay? So these edges are tuples corresponding to the edges that we wanted to add, okay? Now, we can view the number of nodes and the number of edges for a given graph by calling the function number of nodes and number of edges from the NetworkX module. So it just so happens that the number of nodes and number of edges both equal 4, but if they differed, you would see that just by calling this. And again, I put it inside a nice F string so it prints out nice and neat for you guys to read. Okay, so that's how you can build a graph, and that's like the basic thing that you need to know how to do is how to slowly build up a graph. But it's nice to visualize graphs. This is one reason why graph theory was so appealing to me as an undergrad, and probably how I got started in it and eventually got a PhD in graph theory, was that you can visualize things. Now, we have to remember that the visualizations are not really the graph from a mathematical point of view. The graph from a mathematical point of view is literally this. This is all you need to describe a graph, the nodes and the edges. However, because it's nice to look at things and sometimes we can gain insight into structural properties of the graph by looking at it, we should know how to draw the things, right? So, and there's all different ways to draw graphs. And the most basic way is to call the NetworkX draw function. So you just pass in G, and then you'll get something like this. And if you go to the NetworkX documentation, so like the reference drawing, you'll see all the basic ways to do this. So for example, you can like play around with this. I see draw circular. What's going to happen if we draw this graph in with this function? So just come back over here, press shift enter. So you can see that it changes it. And again, it does not matter how you draw the graph, they're all the same, different drawings of the same graph, they're all the same. It just so happens to be that sometimes drawing it one way looks better to the eye than other ways. And this is a pretty simple, this is a pretty basic graph, so the different ways of drawing probably won't illustrate why they exist. However, if we look at a more complicated graph, so this Barabasi-Albert graph with 150 nodes, so we can make, these are one of the built-in graphs inside of NetworkX. So see right here, nx.Barabasi-Albert graph, 150. And these are parameters, you don't need to worry about it. It's just a random seeding thing. And then this is like how the edges are connected. Again, you don't need to know this. That would be more along the lines of like a network science course. But I just wanted to make this and then draw it so that you can see that it gets really messy, right? Like, yeah, this is fine. But here, the nodes are like starting to form like blobs, right? And like, what if I did like 250? Then there's even like more blobs, right? Like it's kind of hard to see what's going on here. So we should maybe learn to draw it a little bit better. And drawing graphs in programming languages is not the easiest thing. It's very tedious. So I took the time yesterday to kind of distill the easiest way for you to draw things. And there's hundreds of ways for you to draw graphs. However, I think that this little like cheat sheet here should work anytime you want to view a graph. I couldn't think of a place where this wouldn't work. So let's go through this so you can understand what's going on. So when NetworkX draws a graph, it's building on top of the matplotlib Python package. And knowing that we can take hints from matplotlib, like if you've ever plotted things in matplotlib, and apply that to drawing networks. So here are the steps that I suggest you do. First, set your figure size. So maybe I typically like, for networks, maybe like 12 by 10 is my fig size. So it will make the figure a little bit bigger. Now here, POS here is a way of positioning the nodes of the graph when you're drawing it. And there's a bunch of different ways to do this. And I found, for whatever reason, this position, so if you do nx draw commit a colleague and then pass in your graph, you set that to be your position for your nodes, it tends to work well when visualizing the graphs. Again, there's no really, I can't really explain why. It's just through me drawing a bunch of graphs, that was the one that seemed the easiest for you guys to use, right? So after you set the positions of your nodes, you then can make a dictionary describing what the nodes should look like. I usually call this dictionary node options. So this dictionary, you can then unpack and pass into this NetworkX draw nodes function, okay? And this will draw only the nodes of the graph, and the way that it draws a node will be according to the dictionary that you make. And you'll see what I mean in a moment. And then you do the same thing for the edges. You make a dictionary describing the properties of the edges and pass that into the NetworkX draw network edges function, and it will draw the edges according to how you want. And then finally, just call plot.show to show the file. Okay, so let's look at what's happening here. All right, so I set my fig size, so 10.8, not 12.10, whatever. I set my position, and then here I make a dictionary describing the basic properties of the nodes that I want, like how I want them to appear. So I say my node color is black, and my node size is 30. And then for my edges, I say my width is 0.5. The transparency of it is 0.5, so it's alpha. And then the edge color, I call it black. So then, one at a time, I draw the nodes, and then I draw the edges, and then I show it. So let's run the cell. So there we go. Okay, so notice that this looks a lot nicer than that, right? And you can customize this however you want. For example, if you wanted like blue nodes, there's blue there. Now we have a bunch of blue nodes. If you wanted bigger node size, make that at 50. If you wanted wider edges, maybe make this like 3.5. Maybe that's too wide, make it a 2. Maybe a 1. Maybe you want them to be like extra transparent. And maybe you even wanted them to be green. Okay. And again, this is just, you can do all sorts of things just with, you can copy and paste exactly this code into whenever you're looking at networks, and you should be fine. That was my goal. Yes, you can make this more complicated. Like you can put like, you can make the edges like like dashed and pointed and whatever you want. But these are the basic things. Like for the nodes, it's just the color and the size. For the edge, it's the width. It's how transparent you want them to be in the color. Okay. And then again, just so you know what exactly is going on here, if I get rid of this draw edges function, it only draws the nodes. If I get rid of the draw nodes function and only put the edges, it only tries to draw the edges. Okay. So if you do them at the same time, that's when they overlap nicely. Okay. And so now let's look back at our original graph, right? The one that we created. Where is it? This one, right? So we can draw that one like that. But if you remember when we made the graph, right, we named the nodes A, B, C, and D. It would be nice to know what nodes are what, right? Like what is A connected to, what is B connected to? So the way that we can do that is by making another dictionary called node label options. Well, that's what I call it. And then inside that dictionary, you're going to specify what your font color is, what your position of your label is going to be on the node, and pass that into the NetworkX draw labels function. So let's look at what happens when we do that. So here, so again, as before, set our node options, edge options, and then here are our node labels. So we want font size of 15, font color blue, vertical alignment bottom, horizontal alignment left, and let's just see what happens. So there. So now we've specified to draw the labels according to these options, and we get a nice picture. We can see that A is now touching B, A is touching C, B is touching C, and C is touching all of them, right? And again, we can change this. We can make the font size bigger by just doing that, right? We can make it smaller. That's like way too small. We can change the color. And we can change the alignment. Right? We do bottom, we do top, so forth and so on. And you can change the font too, but again, I just wanted to do the bare minimum to show, to give to you so that you can easily recreate graphs that you're looking at. Okay. Now, suppose now that I wanted to make this, right? How would I make this? Well, I see the edges are kind of thicker than these edges. I see the edges are green. The nodes have these labels. The nodes are red. So how would we make this? Well, there is a method that we haven't seen just yet that I'm going to introduce. Now, I was hoping when I sent out when I posted this notebook on Blackboard that all of you went and tried to do this, and you could literally just like copy this, like make an empty graph, and then add each name one at a time, and then add edges one at a time, and then set the node options and edge options and label options so that you could draw this. Now, that will work, but there's actually an easier way that we can do this, and that is the following. We can say G is equal to nx.graph. So let's instantiate an empty graph. And now I'm going to make a list of all of the edges that I see appearing in this graph here. So edges, maybe, so the edges are going to be tuple. So I see like Ben, and then Randy, it's one edge, comma, it's another edge. It's going to take me a second. Then Andrew, another edge. And then bear with me as I type out all the edges. I don't like it when they don't align properly. So then let's just keep on going. See if I can get all of them in there. And there's quite a few here. Slowly working my way through. And see. So far, so good. And then finally, I think there's one more. So now that I have like this proposed list of edges, I can just do g dot add edges from, and then pass it that list. And so I made a list of all the edges. Hopefully I got all of them. And then I can just pass in that list to this method here. And then these edges will be added and the vertices will be added at the same time, right? So I can just quickly do like a print statement. Nodes of G are G dot nodes attribute, close that F string, put a new line character in there, print the edges of G are, and then G dot edges. Okay, put in a new line character, that. So we see the nodes now are, it automatically will add nodes if they don't already appear in the graph. So then Randy, Andrew, Morgan, David, Dana, Jeremy, we're all added. Okay, looks like all of them. And then the edges should be all of those edges. So now if I want it to look like this, right? Let me just come up here and like maybe copy this there. So I want green, kind of thicker edges, red nodes, blue font. Okay, so I want the edges to be green. I want them to be kind of thick. And then the nodes to be red and the font color to be blue. Okay, let's see. So it's not the exact same graph, I don't think, as, let's see. No, it might be, actually. It might be. Right, so that's basically how you would do that. Okay. Okay, so that will be it for this recording. So I'm going to go ahead and stop the recording now.